guys, thanks for tuning in. I'm going to go over Materializer now. It's going to be a long form tutorial. It's not going to be formally laid out. I'm just kind of gonna walk through the workflow with you and show you how everything works out. I guess the first thing you want to do is make sure that you install the Materializer package. You probably already downloaded it from the Facebook page and you've got a zip file and you're wondering what to do with it. So you just need to decompress that file and then drop it's still called Voodoo right now because I'm not done renaming it, but you need to drop the Voodoo folder into your assets folder. And doing so will give you a whole bunch of stuff. You're going to notice that the bulk of it is this brushes folder, and the brushes contain a lot of the base image information that we start with. So if you were to look at some of these different ones, you'd see these are 2K maps that we use to generate stuff with. Let's see. We have a couple of demo scenes, but I think I may have pulled them from the version that you have because they're probably not too interesting for you. You have the editor folder, which this is where all of the compiled code that makes up Materializer lives. You probably won't spend too much time in there. Let's see. There is I had to pull it from the version that you have because it would have made the file too big, but I'll make it a separate download. But there's this folder here called prefabs, and in here I have a whole bunch of pre-made materials that you can just drop onto things. So for example, if I go to Unity and sorry, I'm a bit lost. It's the Unity 5 beta, and they moved a few things around. Okay, 3D object. Let's just put a sphere on the scene here. So now if I just drop this material on here, well, I've magically turned it into a PBR material, this being a aluminum variant. So I can make this a separate download if you guys just want to play with, dragging and dropping some materials around on your scene. That's definitely one way to do it. But that's not really the workflow that you would normally use. Most cases you're going to be trying to make textures that describe multiple materials at one time. So you need a solution that'll let you, take your your texture map and describe leather and steel and dirt and rock all in one texture set. That way you don't have to maintain all these different ones, and keeps your memory down, keeps your draw calls down, and all that good stuff. So yeah, I'll zip that up too so you guys can have access to that. I'm just gonna undo that so we just have an empty scene here. The next thing we'd look at will be this textures folder, and inside of textures you will see another folder called temp, and temp is the working directory for your Materializer projects. So you'll see here this cuber folder that I have. It's got all these subfolders in here that contain information and different images, like some ambient occlusion information, color mask information, compiled data, or compiled image data. Some configuration folder contains backups, information about edge masks, effect maps, our gloss mapping, our base materials, our metalness maps, our normal segmentation maps, our normal maps that we currently use, our specular data, and our transparency data. And you'll see that in each of these folders there's 2 files, 1 and 2, and that's because the project that I'm working on actually defined 2 separate materials in that object. So you get to work on each one separately, and then at the end of the process you compile and merge them all into one map set. So real quick, I'll show you how to get into Materializer, and then we'll kind of come back and start explaining the environment setup there's some things you're going to need to do first, such as getting your PBR shader installed, and if you want to use something like SkyShop or any other IDL solution, you need to get that set up first. But just getting into Materializer, you can do that a couple of ways. You can go to Window and into UtopiaWorks, Voodoo, and go to Voodoo, and this will launch the tool. And you'll spend probably most of your time in this environment here, describing what your materials are, and just tweaking out all the things you want to do. So we'll close that. You'll notice here that whenever you close this window, you'll get this dialog saying it's checking in all these different files. And the reason it does this is because of the way that the asset database in Unity works. We need to work with files at a larger resolution than they need to be stored. So as Materializer is working, it's using the full resolution. But when it's done, it will shrink them back down and keep your asset database smaller and free up more RAM for you. Because if you're using the 32-bit version of Unity, you will notice that, or you probably have noticed that it's not great with memory usage. So this is just one of the things that we do to help maintain that. Another part of it you'll use will be the new project window. So if you pop this up, this will give you a tool that will let you create a new project. So if I click in here and say new thing, and let's say I want to select a mesh that I want to work with, so I'm going to work on my blast door example that I've used a lot. My color mask file, and I'm going to come back and explain what some of these are a bit later, because I think probably a lot of you may not be familiar with it. Here's my base color map, and let's get my base normal map, and let's get my base ambient occlusion map. Right now, it's asking me a few other questions. What is my project resolution? What do I want these maps to end up being? And you can go from 256 to 2K maps right now. Once Unity 5 is out and they have the 64-bit editor, I'll re-enable the usage of 4K maps, but it's just unusable right now with the amount of memory it uses to make these 4K maps in the existing 32-bit versions of Unity. So just to keep this demo going fast and keep all the computation down, I'm going to run a 256K map, which you'll still get some pretty stunning results out of, even a texture set that small. So next we're going to look at the target shader model, and this is pretty much saying what shader do you want these to be fed into, because we're going to end up making your maps different at the end of the process depending on what you select here. So we support Alloy and Lux out of the box. They're actually pretty similar in their input style. Then we have a Marmoset workflow and then a legacy non-PBR workflow, which honestly I will probably pull from the product because I don't see too many people wanting to use that anyway. There is a Unity 5 workflow as well, but it is not published in the version that you have because you probably don't have Unity 5, so it's not going to do you a whole lot of good. But I have tested it on Unity 5, and it works 90% of the way so far. I've got a few tweaks to put in. But yeah, so for now I'm going to leave it under the Alloy and Lux model. Color matching, I'll just briefly explain this. This color mask, this is a color representation of different areas of your UV map. So if you use a program like Maya or 3ds Max or whatever modeling environment you use, in there, when you're making your UVs, you'll be able to make a UV wireframe. And once you have that UV wireframe, you can export that to something like Photoshop or GIMP or whatever you use, and lay out your different material segmentation. So in this example, I'm telling it that this yellow area is going to be one material, and this green area is going to be another material, and this purple is going to be another. So this one piece of, this one map provides a lot of information to Materializer because it says, okay, I'm going to need to split this up into 6 or 7 different pieces of this project, and each of these is a separate material, but when I'm done and I'm making my final compilation, I will merge them all together. So the color matching is a threshold that you can set, because you're going to have instances that you have a color map or a color mask coming in, then you did it in Photoshop with anti-aliasing, and just these little minute color differences on the edges are, if we didn't do this color matching, you'd end up with thousands of different colors, because a 24-bit color palette gets pretty big. So color matching lets you adjust what you want the tolerance to be for matching similar colors. And saturation is a setting that says, if there is one small tiny piece of the map that's, like 4 pixels by 4 pixels, just ignore that. That's just noise. So the saturation value lets you adjust what you want to do with there. The edge width, you may or may not be familiar with this, but in a lot of pieces of software like Materializer, you're going to make a base layer, but you're also going to have to work with details along the edges. So imagine if you were working on making a wall, and that wall, obviously the middle of that wall would be, in the real world, a pretty solid color. But over time, dust tends to collect around the edges of things. So this edge width tells us how far from the edges you want those effects to bleed out. So our edge detection algorithm will take that base finite edge that it finds, and then whatever you adjust this edge width out to, it'll go further out from there. But I'll just leave it at 1, and I'll click Bake, and we'll see that it starts to break this map up into smaller maps. And once that's done, we'll take a look at what it creates. So yeah, you can see it's going through them pretty fast here in this 256 version of it. If you were to run it at 2K, it'd take a bit longer to go through your map, because it's looking pixel by pixel and comparing what colors match, and what pieces they should go into. And this will probably all make a whole lot more sense to you here in a minute once it finishes. Okay, project was successfully created. So now it's going to close, and we'll see that it created a new project for us here called New Thing, which is what we named it. So now if we go and look at our AO, okay, so it took that information that we provided and created these ambient occlusion segments. Our color maps, our compiled data, so it knows all the different pieces of it. Here's our edge masks that it found. Our base gloss and metallics are probably going to be black. So what does this all mean? So let's open the main window again, and we'll take a look. And here we're going to select our project. There we go. So it took that input mask that we provided and created all of these separate maps. So now each of these can be treated as a different material. So if I were to select this area and come over here and pick an effect I want to put on it. So let's put, let's put this, it should be bronze. Yeah, so we put bronze on it. So we have our starting window here, and then we have a new window here. So what we're going to do is we're going to click here, and that's going to give us our little mousy, scrolly, draggy dialog. And I'm going to click here to connect it. So now I've created a workflow that says start here and go here. So you can add as many of these as you want along the chain. So I'll connect this one to this one. And you can do this as much as you want. Just keep in mind that the more of these that you put in, the longer it's going to take to compile your maps. So let's reset this and let's start from scratch again. So no, we don't want to use bone. We want to use bronze. Okay. So I will start from here and attach the core to bronze. And now I need to pick some other options. Bronze type. Do I want a smooth, rough, or raw? Let's just start with smooth. Do I want my normal maps inverted? So in some cases your normal maps are going to be generated and they create surface area, they create surface effects like, bumps and different pieces of what's the word I'm looking for. It creates surface detail in the normal. Well, you can invert that to where that actually carves in this way. Now, what do you want your normal mapping mode to be? Do you want, hey, I just want to ignore normal maps. I want to use only what came from my base normal map. Do I want to blend this normal data that's coming from the bronze effect with my base normal? Or do I want to make it opaque to where it's just the normal map coming, or the normal data coming from my effect? So I'm going to do opaque. I'm going to tell it, hey, how deep do I want my normal map to go? I want it as deep as it'll go. And do you want to add any smoothing to your normal? You can do that. Do you want to rotate this base texture at any degree? So if your UV data were set up in such a way that your geometry was at a 45-degree angle, well, you could adjust this slider and say, hey, I want it to be at this. So this goes from 0 to 1. So just kind of thinking about, hey, 180 degrees would be 0.5. So, but I don't need any rotation on the example I'm going to do here. So I've selected my map, I've defined and described my material, and I'm just going to click paint. And this is going to go and start painting just that region of the map in this bronze material. And that's splitting it up into the different layers of the PBR output. So that's giving your albedo map, your specular map, your normal mapping, your ambient occlusion mapping. So all the different pieces that make up into feeding a PBR shader. Okay, so that's done. So what we can do is come to this guy and we can right click and say, hey, show me the diffuse map, and it'll bring it up. Okay, now again, this is a 256K map, or 256 map. It's not a massive file, but you can start to see some of the detail that's come in here. So this is just our albedo data. This is in our diffuse channel, so there's not a whole lot of brilliant color happening here. Well, what is in our normal map? All right, well, let's see what's in here. Okay, we got some basic normal data. What about our specular area? Okay, so now this is the specular or reflective colors that are going to be coming off the material. All right, well, what about all the others? So you can kind of go through all these and just see what your output what your outputs are going to be. So we'll come back in a bit and build out some of these others, but I just want to show you real quick the basic workflow. So yes, you would go through and you would define one segment at a time. Hey, I want this to be bronze, and I want this to be leather, and I want this to be gold, and I want this to be denim, and you just define them all that way. And when you're done, you click merge, and this is the process that actually goes through and starts to compile all of those different settings into our final output maps. So here we go, we're merging our maps, our diffuse, our normal channel, our specular channel, transparency channel if you wanted to use that, your gloss data, your metallics, your AO, and we're done. So I will just minimize this for a second. So now if we go back to our new thing folder, well, here are our PBR balanced outputs. So if you didn't notice, when we created the new project, it actually put a piece of the geometry on the scene for you. So now what we need to do is to feed this into that geometry. And this is where you're going to start to have a few different ways of doing it, because it depends on the shader you want to use. So if we wanted to use Alloy, we'd have one way. If we wanted to use Lux, we'd have another. Unity 5, you'd use the standard shader. So what we're going to do is we're going to create a new material. All right. And so this is the Unity 5 beta, so here's a look at the standard shader. But we are going to use Alloy Core Base Bumped. Okay, so this is the basic Alloy shader, and what I'm going to do is start attaching my maps. So I'm going to take my diffuse maps. You can see they're named. Let me see if I can. You can see they're named. So, AO, diffuse, gloss, metallic, normal, specular, etc. So I'm going to take my diffuse map and drop it here. Blip. And I'm going to take my normal map and drop it here. Okay, so now I'm going to drop my material on my object, on my geometry. Alright, now there's a big piece of this that is missing, which is the specular. And the way that Alloy works is a little different than the way that maybe Lux or Unity 5 shader works. In Lux, you would just take this file, the new thing specular for Lux, and drop it here. And voila, you have PBR information. So, but Lux is a little different than Alloy. Alloy is you need to go to Window, Alloy, Material Map Channel Packer, and this tool is what you use in Alloy to create your specular, because what they do is they take channel information from each of those outputs in RGB and A and make your specular map from that. So using this tool, you would say, okay, I need my metallic. All right, well, this is my metallic, and I will drag and drop it here. I need my ambient occlusion, and I'll put that here. By default, oh, looks like I hit the wrong one. Let's do that again. AO goes here. And our specular, this is our base specular, goes here. So by default, when you launch this tool, it'll have specular set to white. You just want to change that to texture. So now roughness, this is where the vocabulary in different shaders varies, because some will call it roughness and some will call it gloss. And really, they're just different ends of the same spectrum, but they're pretty much the same data. So we're going to take this gloss map and put it here in roughness. And finally, we're going to put the normal map here. And something to watch out for with Alloy specifically is this yellow text here. This is telling it where it's going to go. By default, it just goes to the assets folder, but if you click on the folder where you want it to go and come back here, it'll remember that. So we're going to generate our Alloy map, and you'll see that it gives us a couple of files. So we're done with this. We can close this. Let's put this back. So now we got a new material PM file, and then we got an actual PNG file, and that's what we want to use. So let's go back to our new material guy here. This guy, and we're going to drag this into here, and we get a much cleaner result out of that. So now we can look at some of the other parts of Alloy that make it nice. You can actually adjust your metalness on the fly. You can adjust your specularity on the fly and your roughness. Another nice thing is if you have something like SkyShop, you can change it and tell it to use the SkyShop IBL data that's coming through, which I don't currently have set up in this project, but I'm about to put in. So that is the basic workflow for using Materializer. I'm going to pause the video for a second, make a couple of changes to my machine because it is running really slow right now, and I'll come right back. Alright guys, I'm back. Sorry for the interruption there. So what we're going to do now is we're going to add SkyShop for image-based lighting to our scene. So the first thing we need to do is we need to create a new SkyShop, or a new skybox. So you can see that there's actually one that's already being shown here, and apparently I found a bug in Unity 5, and I guess I need to report that because while I had the camera off and I was testing, I put a sky in, and when I got rid of it, it stayed. So yeah, there's the mystery of the universe. But for you to add SkyShop, you would go to Window and bring up the SkyShop dialog. And here you would find the HDR image that you want to use, and I happen to know that I want to use the forest HDR image, so I will click on that. Yeah, fix that. So this is an HDR image, so it takes a little bit longer to load up, but it's definitely worth it. So now we get this nice crisp HDR cube that's going to be put into our scene. And I'll click New All, and that'll prep the specular and the diffuse cube map. And I'll go ahead and do a GPU compute because this is a lot faster. I don't know why they still have the traditional compute button, but they do. And this will actually create the skybox images, so now you see we get the images that will be in the cube maps. So I'll click Add to Scene and close this dialog, and you'll see that we get this guy called Forest, and it's got some settings over here that we'll come back and take a look at a little bit later. Another thing that we need to add to the scene is a sky manager, which would be under game objects, create other, SkyShop sky manager. And the sky manager is important with SkyShop when you want to have multiple skies within the same scene, and you want to be able to have your geometry transition between the two of them. Let's say you had a ball that was rolling from outdoors to indoors. Well, you could have an outdoor skybox as well as an indoor, and then as it rolled from one place to the next, it would the image-based lighting would change for it. So our sky manager is there, and you can turn the skybox on and off that way. And our forest is the default sky that we're going to use. You don't really have to do much beyond this by default, but you can go in later and add trigger regions and projector regions if you want, but for the sake of what we're doing in this demo, we're not going to do that. So there's our sky, and I had to remove the maps off of this so I could continue the demonstration. So let's get back to Materializer. So we'll go to Window, and we'll go back to our new thing project, and you'll see that I actually went ahead and did some of the other maps as well, and that's okay. I left this with bronze, and I put a rubber texture on this guy, and a plastic texture on something else. Now, another kind of cool thing you can do with the program is, if you want to see what you've done in the past, you can right-click on any of these guys and go to Properties, and it'll show you a chronological history of what you did. So your newest stuff will be at the top of this list, so if you just click this, it'll close that window and recall what you did. So if you wanted to see what settings you used before, you just bring up Properties and see, here's some of the different ones I did before, and I want to use the newest one, and there you go. So it'll remember all the settings that you used to generate that layer. So yeah, so let's go ahead, and since I've already got them set, just for the sake of time, let's go ahead and merge them all down again. Alright. So now we've got some different materials to look at. So let's go back to our material, and let's regenerate our alloy specular file. let's drag that back onto here. Let's try it. Okay, so now we can start to see what's going on here. So we've got our rubber materials and all of our different pieces that are starting to work together. I'm going to close this window down for now. Let's go ahead and free up some memory. All right. Just about done. Alright, so now that's done, and we're going to start looking at some of the different things we can do. So let's change our, under alloy, let's change our reflective properties to SkyShop. And now we're going to start reflecting our environment. So we've got that forest cube map, and you'll start to see that in the reflective properties of this. Okay, now we're going to talk about the workflow for using Lux instead of alloy. So assuming that you have downloaded and installed the latest version of Lux, we're going to do a couple things to get that set up. The first thing you need to do is to create a Lux game object container. So we're going to create an empty game object, and let's just call it Lux. And we're going to add a component which is going to be their script called setup Lux. And here is where you set your global environment variables for Lux. So you can do things like, what type of lighting you use, blend Vaughn, Cope Torrents. You need to provide the cube maps that you want to use for your environment. So in this case with Lux, you get one cube map setting. You don't really get the luxury of SkyShop to where you can have multiple in the same scene. So we'll select the same ones we used before. So we'll use the forest sky, and then we'll use the forest specular here. And let's go ahead and tell it that these are HDR. We'll come back and play with those settings here in a second. So the next thing we want to do is to create a new material. And we'll call this our Lux material. And we will change it to the Lux Bump Specular Metalness shader. And let's go ahead and put that on our model. So now we're going to take the same maps that we did in Alloy, but use them here. So we'll take our diffuse map and we'll put it here. And we'll take our normal map and put it here. And you'll notice that there is an existing file that got made called the specular for Lux. And if you use that, you'll see that it's going to be a little different than the one that we made with Alloy. So we'll put that there. And now we're starting to get some of our environment settings. So let's go back to the game object we made. And here's where we're going to start messing around with the different IBL components. So what's the HDR scale? What's the specular exponent? What's the diffuse exponent? You just kind of tweak these out to where you want them to be. And you start to see how it works. But again, it's not the same as Alloy. It's a little different. Now you can take if you have Alloy and Lux, you can actually put this one here as well, and you'll get a much better result out of it. But it's just the way that Alloy compiles their specular outputs. So by now you may be asking yourself, this is all well and good, but where do I get these color masks from? These mysterious, colored files. So I'm going to show you an approach you can do in Maya, and it's a pretty universal approach in most 3D programs, but we'll take a look at it here. So we'll make a very basic cube model, and I'll show you how you can create those maps. Looks like Maya's over here. Let's bring it back here. Okay, so let's do this. Let's go to our polygon menu and let's just put a cube here. Alright, there's our cube, and let's create a basic automatic UV mapping. So when we go to look at the UV texture editor, this is what you get from automatic, which is fine. You could actually use the planar mapping or use the camera based or automatic, spherical. This is the default cube map, and that's fine, but I like to use the automatic in the case of cubes because it just gives you more surface area for your UV. So we'll close that down. And alright, so now we've got our cube object, and let's go to face mode. And I'm going to select that face, and I'm going to assign a new material, and I'm just going to put a Lambert, however you pronounce it, on there. And I'm going to give it solid color. Alright, so there's our red face. And we'll do a new material here. And we'll make this one blue. And you can imagine how you would do a more detailed version with a more detailed model, but this should suffice to explain to you how this is done. That's actually not what I wanted to do. I wanted to select this face. There we go. So assign a material. And this is probably a nice thing to know for our non-modelers out there. How exactly you do this, in case you ever wanted to know. This is a way to do it. Another way is you can just take your UV map and bring it into Photoshop and start painting. But this is a little more accurate, at least for making a base. Base map. So let's get these last two areas. Let's give them some unique color. Alright, so let's get this last face, and we'll put a new material on it. About that. Alright, so now we've got 6-sided cube with 6 different materials assigned to it. So if you take this back to object mode and you in Maya kind of scroll through this, you'll see we've got all the different pieces of the puzzle, so to speak. So what we'll do next is we'll highlight that cube and we'll duplicate it, Control D. And now we've got 2. So what we're going to do is we're going to bake out our maps. So in Maya, if you switch to your rendering menu and go to lighting and shading and transfer maps, you'll have this dialog pop up. And what we're going to do is we're going to say, hey, this is our source map, so add selected, and this is our destination map, add selected. And what you want to do now, and this is a very, very important thing, is you have to lay these 2 pieces of geometry directly on top of each other. So it's probably best if you manually dial this in on this second piece of geometry. So let's go back to our settings and let's put it, well, let's just put them both at 0. Here it is. And we'll do the same with this one. So they are directly on top of each other. Um, this is a method they call caging or mesh caging, and there's different ways you can do this. You may want to slightly offset the scale of one just a little bit bigger than the other. And what it'll do is, as the light rays are passing through it, it's just going to give you a more accurate result. So we've got this cube map and this one, and now we need to tell it what maps we want to make. So we're going to tell it, hey, I want a normal map, I want a diffuse map, and I want an AO map. You can add the different ones that you want here by just clicking on them. So let's give this a place to go. So I'll just put these on my messy desktop. Make a new folder called cube, and we'll call this normal. So you'll see that set it to my desktop. No, it didn't put it in cube. Where did my cube folder go? Oh, I didn't tell it to go to cube. Okay, normal, and we'll put the diffuse in the same place, and we'll put our AO in the same place. Okay, now you'll see that Maya doesn't want to make a PNG version of the AO. It's just part of that plugin, so be sure to change that to JPEG. And what you do now is you go down to your common settings, or your common output, and tell it how big you want your maps to be. For the sake of this demo, we'll just do it at 256 because we don't really have a whole lot of detail here. And this is also the process you would go to for baking down, the map data from a super high poly mesh into a low, a low poly topology, new topology. So we'll do this, and we'll say bake, and we'll get the little indicator going on down here, what it's doing. And this may take a couple of seconds for the AO. The AO normally takes a bit longer to do. And like I said earlier, you'd work with more complex geometry than a cube in most cases, but you can also get pretty creative. So if you're working with something like a space rifle or something, you can really think about your materials and how you want it to build it out. So, if you want to use a common material across, the trigger and the barrel, well, you just make them both share the same material or the same color, or yeah. So, you can really go in and just define different regions of your 3D geometry and specify, hey, I want this to be rubber, and I want this to be plastic, and I want this to be glass. And once you have that, and it makes these color masks for you, you bring them into Materializer to actually start building out the materials that will become what you see at the end result. So let's let this AO finish baking out. I guess we can take a look at the others while that's going. So, voila, here is our diffuse color map. Ain't it pretty? And here is our basic normal map. And we'll just let our AO finish. Maya has finished baking out our AO map, and you can see it here. It's incredibly complex, and it took it 10 minutes, but that's Maya. So let's go ahead and close this out. And now I'm going to show you another way that you can make these color maps. So assuming that you have access to the geometry itself, or you have access to the artist who made it, we are going to take the UV wireframe. So let's do this. Let's go select our model and go back to the UV texture editor. And we are going to say polygons, UV snapshot. And let's put it where we had our other stuff on the desktop, cube, and we'll just call this wireframe. And we'll save that, and what the, we'll make it 204A, and we'll make it white. Okay, and that'll bake that out, and now we have a wireframe. So what we're going to do now is open this wireframe in our trusty Photoshop. So this will let you get a little more creative with how you want to define your color masking. So as soon as this opens, and you can kind of see what's going on here. So what I'll typically do is make a new layer and give it a solid color mask here. Let's just do a solid color overlay. Just fill it in. Okay, so that's our background, and I'll normally just go and put like a stroke on this just so you can kind of see it better. And when you're ready to export it, just undo the stroke, but it kind of gives you some some sense of region of where your UV is. So from here you can just get creative as you want. Again, you need to keep it in solid color. You don't want to get in here with the paintbrush and a bunch of gradients, because that defeats the purpose of what you're trying to do. But if you wanted to come in here and say use your bucket tool and do something like this. Okay, so now I've defined that region is going to be that material, and this will be this. But I can also go in and further define and draw another region here and make that blue. Oops, go back to my bucket tool. So now you can see how you can really get in and be as creative as you want. If you wanted to put some lines here and a big circle here, you can come in and use the polygon tool and put yourself a big fancy star here. And there you go. So now you just take the background away or leave the background. It's really up to you. Otherwise, it's just going to treat that background as a material. Save this out. We'll put it here, and we'll call it custom. Click Photoshop, and now you can use this mask instead. So that just kind of gives you a sense of how these color masks are made. There's probably a dozen other ways you can do it as well, but those are the ones I know. All right. Well, I think that about wraps it up for just the introductory tutorial. I mean, there's some other stuff you'll get into with it, and I'm sure you'll have lots of questions, but I'm not going to guess at what those are going to be for now. So thanks, and please let me know any feedback you have. Thanks.